Hi folks. So today we will talk about the topic in a more general architecture, but it's important for the self-sovereign identity too. And in my previous video, if you haven't seen it, we talk about the monolith, microservices, and the architectures that's sitting in between. But one valid question about the monoliths, even if they are highly modular and so on, quite often the execution environment is the single machine. And how we could create, let's say, execution environment that capable to utilize the multiple distributed nodes, distributed machines, but still something that are maybe not so granular as the microservices and do not require some crazy things like Kubernetes and so on. So in 1972, it was the Carl Hewitt that created the theory of actors, and actually it's a completely different mindset and it's completely different approach, and the main target of this approach actually was to tackle the computation limits of the resources at that time, and save developers from lunatic asylum, because the multi-threading, multi-computing and so on was extremely complex topic, and people need the system that allows to utilize the resource more effectively and allow parallel computing and all other things. So the actor system, it's the mathematical model, it's quite important. I really recommend you to read the Carl Hewitt original paper because you will understand much more. But if we take the short summary, you have the actors. Actors have their own internal state, they not share the state, it's completely isolated. And you could send the message to the actor, you could get the message from the actor. Actor on the message could change his internal state, or he could send, as I said, send and receive the messages, change the internal state, or what's more interesting and the cool feature, create more actors. And that's it. So it's quite simple mental model that on every tick in a system you have the huge scheduler that somehow distribute resources among the actors. Multiple systems have the multiple different implementation of this, but in one tick of the system, actor could do one action. Yeah, to change the state, send the message, and process the messages from the letterbox and so on. So it was the mind-blowing idea, and a lot of software based on this idea, and it's the scalable thing. So you could apply it, for example, as Ericsson did with the Elixir, to real-time systems in a telecom. So for example, Elixir and Erlang is the Ericsson language, have the actors embedded in a language, but the actors, it's the lightweight parallelism, and every actor have some kind of Erlang process that was completely isolated. That's one approach to implement the actors. Some other systems take the opposite extreme, that for example Microsoft create Orleans actors. So that's the actors that are ephemeral. So if you don't have the messages in a letterbox for the actor, you actually don't have the physical instance of the actor. So the actors is a huge topic. It's applicable on UI. You can take a look my video about the X state. It's applicable on the backend systems heavily. So the Scala community have the Arca, the Scala community have a lot of projects built on actor, the Rust community have the Actix, and it's yet another actor system. But why we talking the actors in the terms of scalability? Because it's the high performance system that allows you to build the clusters. So it's the actor systems allow you to take a couple of machines, glue them to the cluster, and it's the pattern to the scalability that are a bit different from the microservice architecture. Yet another quite interesting project that really brings a new view on actors is the Wasm Cloud, where you could glue machines to the cluster, and every actor is the WASM module, and they use some communication channels like NUTs and all other things. So it's yet another scalability pattern. It could be, actors could be as a hierarchical structures with the the monitoring and corrective error handling, or they could be slightly different architectures, but it's applicable on UI, it's applicable on backend. But what quite interesting that you talk with the actors via the addresses, and address is not the direct access to the actor, it's just the address in the network. And with this separation of concern between the address of letterbox and actors itself, you have a huge scalability. And not just scalability, but amazing abstraction, because with this address actually you don't know to whom you talk. And it could be a remote machine, it could be IoT device, it could be your phone, as far as they connected to the network. And you have the routes and you have the routing rules. You really could manage the message passing effectively. I really recommend the books like Actor Patterns and Message Patterns. It's really good. It's applicable more for akka, but majority of the patterns are really useful for other application. How this topic connected to the SSI? Actually, SSI have the concept of the active SSI engines, and a lot of patterns from the actors really applicable in this space. So it's actors is yet another scalability and yet another architecture pattern. It's completely different mindset. It's quite a simple mental model. I really recommend you to read about this more. I will leave the mind map in a video about different actor styles, different architectures, different framework in different languages. I will be happy to hear more. Please subscribe to our channel, share this video, be open for donation. We have the Patreon, we have the PayPal, whatever. So let's build the future together, and see you in my next videos. Cheers.